Jellyfish can learn, even though they have no brain. Scientists have discovered that jellyfish can learn from mistakes. Although they have no brain and only about 1,000 nerve cells, these creatures can learn from past experiences and change their behavior in response. This research challenges previous ideas suggesting that advanced learning requires a centralized brain and sheds new light on the evolutionary roots of learning and memory. Jellyfish are more advanced than previously thought. A new study from the University of Copenhagen has shown that the ankle jellyfish Tripedalia cystiphora, an animal endemic to the Caribbean Sea, can learn at a much more complex level even though they possess about 1,000 nerve cells and no centralized brain. The evolutionary success of jellyfish is undeniable. They are some of the oldest creatures on Earth. They appeared on the planet 500 million years ago and were able to adapt to the changing world better than trilobites or even dinosaurs. Yet they are mostly thought of as simple creatures with very limited learning abilities. Jellyfish and their relatives, anemones and corals, species classified as cnidarians, are believed to be the earliest living animals to develop a nervous system. The one in jellyfish consists of only about 1,000 nerve cells. These cells form a loosely interconnected network that wraps around their gelatinous bodies and helps them sense their surroundings, detecting changes in temperature, light and, of course, touch. The prevailing opinion is that a more advanced nervous system means a more advanced learning potential in animals. From this we can conclude that animals with a simple nervous system, such as jellyfish, are only capable of basic forms of knowledge acquisition. And this, as it turns out after recently conducted research, is not entirely true. For over a decade, neurobiologist Anders Garm from the University of Copenhagen has been studying ankle jellyfish, Tripedalia cystiphora, which are widely considered to be among the most poisonous creatures in the world. But these inconspicuous creatures are also interesting for another reason. It turns out that they are not as simple as once thought. And this undermines our entire understanding of what their simple nervous systems are capable of. These jellyfish measure about 1 centimeter in diameter. They can most often be found in waters where mangrove forests grow. They feed on small crustaceans and use their 24 eyes to do so. Their favorite item on the menu is Coke pods. But these hide near roots submerged in water. When hunting, they risk injuring their soft bodies by rummaging through the thickets of roots. Garm and Jan Bielecki from the University of Kiel in Germany wanted to find out how these jellyfish avoided serious health damage for millions of years as a result of having their bodies torn by a protruding, sharp root. They conducted a series of experiments using circular tanks lined with grates to imitate mangrove roots. The tangle of roots is a good place to hunt, but it is also a dangerous place for jellyfish, whose bodies have a soft consistency. As the small jellyfish approach the roots of the mangroves, they turn and swim away. If they turn too early, they won't have enough time to hunt. However, if they turn too late, they risk hitting a root and damaging the gelatinous bodies. Therefore, distance assessment is crucial for them. And here the key was contrast. Our experiments show that contrast, i.e. in this case the assessment of how dark the root is in relation to the water, is used by jellyfish to determine the distance to the roots, which allows them to swim away at the right moment. Even more interesting is the relationship between daily changes in distance and contrast due to rainwater, algae and wave action, Garm said. One of the most advanced features of the nervous system is the ability to change behavior as a result of experience. The researchers manipulated the jellyfish's behavior by changing contrast conditions to see what effect it had on their behavior. The research team noticed that these jellyfish learned daily to judge distance based on the contrasts present. Combining visual impressions and sensations during unsuccessful dodges that resulted in contact with the imitation root. Therefore, despite having only 1,000 nerve cells, our brain has about 100 billion of them. They can combine the temporal coincidences of various sensations. We call this process associative learning. Moreover, the speed of association was similar to that of animals that were more advanced in terms of their nervous systems, such as fruit flies or mice. The results of this study challenge previous ideas about what animals with simple nervous systems are capable of. The research team also determined where the learning process occurs in these jellyfish. This gave them a unique opportunity to study the precise changes that occur in a nerve cell when it is engaged in learning. Researchers hope that jellyfish will become a model organism for studying the cellular processes involved in learning in all animals. We are currently trying to determine exactly which cells are involved in learning and memory formation. This way we will be able to look inside and see what structural and physiological changes occur in cells as they learn, Garm explained. If scientists can pinpoint the exact mechanisms involved in jellyfish learning, the next step will be to determine whether they also apply to other animals. Ultimately, We will look for the same mechanisms in other animals to check whether this is how memory works in general," said Garm. Such knowledge could be used for many purposes. Understanding something as enigmatic and incredibly complex as the brain is absolutely amazing in itself. However, there are many useful possibilities. One of the main problems in the future will undoubtedly be various forms of dementia. I'm not saying we've found a cure for dementia, but if we better understand what memory is, which is the main problem with dementia, we might be able to lay the groundwork to better understand the disease and perhaps prevent it, Garm said. It was once assumed that jellyfish were only capable of the simplest forms of learning, including habituation to specific stimulation, such as constant sound or constant touch. We now see that jellyfish have a much more sophisticated learning ability. We also recognize the fact that they can learn from their mistakes. In this way, they modify their behavior, Garm emphasizes. In 250 million years, a new supercontinent will form. It will be hot, dry and uninhabitable. Scientists predict that in about 250 million years, the planet's land masses will merge to form a new supercontinent. However, these changes will have a number of disastrous consequences. According to estimates, up to 92% land surface will be uninhabitable. The supercontinent will likely heat up so quickly that many species, including mammals, will be unable to adapt. New research presents the first ever computer climate models of the distant future. They show how climate extremes will dramatically intensify as the world's continents eventually merge to form one hot, dry and largely uninhabitable supercontinent, Pangaea Ultima. Unfortunately, the formation of a new supercontinent is likely to trigger significant global changes that will make the planet an inhospitable place for many species, including mammals. The merger of land masses will result in increased volcanic activity and an increase in carbon dioxide levels. Simulations predict that the mass extinction will be caused primarily by heat stress. The results and description of the research were published in the journal, Nature Geoscience. The Earth is currently believed to be in the middle of a supercontinental cycle. These are processes and events related to continental migration, leading to the periodic formation of a supercontinent and then its breakup into smaller fragments. Scientists estimate that this cycle lasts about 300 to 500 million years. The last supercontinent, Pangaea, broke apart about 200 million years ago. The next supercontinent, called Pangaea Ultima, is expected to form near the equator in about 250 million years, when the Atlantic Ocean ceases to exist and a combined Europe, Africa and Asia joins the Americas. A team of scientists led by researchers from the University of Bristol attempted to model how extreme the climate could become as a result of the merger of the Earth's landmasses. It looks like life will be a little more difficult in the future. "It's a bit depressing," said Hannah Davies, a geologist at the GFZ German Research Center for Geosciences in Potsdam. By modeling the climate of the new supercontinent, Alexander Farnsworth from the University of Bristol in the UK and his colleagues discovered that much of it will experience temperatures higher than 40 degrees Celsius, making most of the areas uninhabitable, at least for mammals, i.e. human. When continents come together and then move apart, there is an increase in volcanic activity. These processes will release huge amounts of CO2 into the atmosphere, which will heat up the planet, Farnsworth explained. The simulation predicts that regions in the center of the supercontinent, far from the oceans, will turn into deserts that will be uninhabitable. As Farnsworth pointed out, only very specialized mammals will cope. In the worst-case scenario, in which CO2 levels reach 1,120 parts per million, much higher than today, only 8%. The planet's surface, the coastal and polar regions, will be habitable for most mammals, compared to about 66% currently. The predicted changes will lead to mass extinctions. This will not only affect mammals, but plants and other types of life. In other mass extinctions, a new species usually came to dominate the planet, Farnsworth admitted. However, it is possible that some mammals will manage to survive environmental changes. It is also uncertain where Pangaea Ultima will form. Farnsworth's model assumes that the current continents will merge near the equator in the warm tropics. But other scenarios suggest it could form at the North Pole. There would be much cooler conditions where life could thrive. As Davies acknowledged, there is some evidence that Pangaea and other earlier supercontinents had large interior deserts. This reduces the area of land suitable for habitation and leads to the extinction of species. Similar things happened during the end Triassic extinction, about 200 million years ago, Davies noted. Farnsworth speculates that if humans are still around in 250 million years, they may be able to find ways to adapt. Will humans become more specialized in the desert environment? Maybe they will be nocturnal. Or maybe they will go underground and live in caves. I suspect that if we could leave this planet and find a more habitable place, it would be more beneficial, he added. Mass extinctions have occurred in the past and will continue to occur in the future. I think life will cope. It's just going to be a bleak period, Davies stressed. It should be noted that scientists did not take into account greenhouse gas emissions caused by human activities in their long-term climate modeling. It is extremely important not to lose sight of the current climate crisis, which is the result of human emissions of greenhouse gases. Although we predict that the planet will be uninhabitable in 250 million years, today we are already experiencing extreme heat that is harmful to human health. That is why it is so important to achieve net zero emissions as soon as possible, said Eunice Lowe, co-author of the publication.